G2 class geomagnetic storm. Weather-dependent individuals, be prepared. Keep track of the magnetic storm calendar for October. In 2025, a solar flare will disrupt the internet.
Probably you've come across such headlines lately. And surely you've heard, even in passing, about the fact that solar activity is on the rise. There will be more storms, and headache pills on pharmacy shelves will be scarcer. So what is actually happening? Have journalists found a golden vein for panic-inducing? Or is the sun truly experiencing something? Get comfortable, my friends, and welcome to the Earthwise Chronicles. We're here to tell you all about that.
Let's start with the fact that our star isn't a static object that shines uniformly upon itself. The Sun is a colossal thermonuclear reactor, its mass accounting for 99.87% of the entire solar system's mass. It would be strange to expect consistent and predictable behavior from such a machine, especially considering that even the tiniest asteroids in our solar system live lives rich with changes. Planets even have seasons, shifts in magnetic poles, and variations in axial tilts. Hence, the Sun is an incredibly active object, ever living and continuously evolving. The star rotates at a speed of 2 kilometers per second at its equator, and a solar day is approximately 25 Earth days. Of course, this holds true only at the equator. Near the poles, a day already lasts 38 Earth days. And one might say that the poles literally struggle to keep up with the rotation at the center. Moreover, every 11 years they switch places. Not literally, of course. I'm referring to the magnetic poles, which change polarity at the Sun about once every 11 years. Scientists don't even know why this happens, but this is where we start finding answers to our intriguing questions. These same 11 years encompass cycles of solar activity.
German astronomer Heinrich Schwab was the first to notice this in the early 19th century. He calculated that the number of sunspots increases and decreases according to a mysterious pattern. Later, Rudolf Wolf and other astronomers refined Schwab's proposal and accurately deduced that the increase in the number of sunspots is not a random process. It follows distinct successive cycles. So what are these spots?
They are dark regions on the star's surface, which are 15 to 20% cooler than the surrounding areas. However, we're still talking about the temperatures of 3 to 4,000 degrees, so the term cool is quite relative when it comes to these spots. And they aren't even that dark. Although they may appear as darkness from Earth, place such a spot in our sky and it would shine just as brightly as the Sun. What appears to us as emptiness is in reality whirlpools of superheated gas. Their sizes can be quite intimidating. For example, in late June 2023, a sunspot appeared under the codename AR3354, whose diameter is 7 times the size of Earth. It was visible from the surface of our planet even without a telescope.
To understand how these spots come about, let's remember that the Sun is not solid and rotates around its axis differently from the Earth. This is why days are longer at the poles. The rotation of our star resembles a whirlpool, and it's clear that this turbulence affects both matter and the magnetic field. Flares, which gather, merge, migrate, and engage in various activities, are the result of these disturbances. These processes are incredibly complex, but two facts are essential for us.
The first fact is that flares often occur in areas with high concentrations of sunspots. The second one is that coronal mass ejections occur in these regions as well. It does sound ominous, doesn't it? Let's delve into why scientists have linked solar activity cycles to the number of sunspots. To put it roughly, an 11-year cycle looks like this. Over the course of 4 years, the number of spots, flares, and and mass ejections grows rapidly and dramatically. Then, for the next 7 years, the Sun quiets down and the number of aggressive events decreases. Ultimately, the hands of this clock complete a full rotation, signaling the beginning of a new 11-year cycle. Currently, we're in the 25th solar activity cycle since observations began. It's believed to have started in December 2019, when the solar minimum ended, marked by approximately 1.8 sunspots per month. By May 2020, this number had risen to 5.6, and in November 2020, it reached 34. By July 2023, a staggering 159 spots were observed on the Sun. As a result, the number of flares and mass ejections has also increased. In 2018, coronal mass ejections paid a weekly visit to astronomers. Now they occur multiple times a day. This, of course, has an impact not only on media headlines, but also on the well-being of weather-sensitive individuals on our planet. However, before we move on to them, it's worth noting that the 11-year cycle isn't the only solar cycle. There is also the 22-year cycle, which consists of two parts. There are centennial, bicentennial, and millennial cycles that, while not yet thoroughly studied, do not raise doubts about their existence. Returning to the main topic of today's discussion, the 11-year cycle is an approximate figure. Some cycles last 7 years, others 17.
This field of science is still too vast for more detailed research. Therefore, anyone providing you with extremely precise figures should be approached with a healthy dose of skepticism.
Regarding the current cycle, it's known that the solar activity is expected to remain at its peak until at least 2024. It might even extend until 2025, but it's also possible that the peak could be reached this year. The only thing that can be said with certainty is that we're currently witnessing a significant number of flares and coronal mass ejections. The last time this happened was in 2014, when an average of more than 100 sunspots were registered per month. In other words, the current solar activity cycle appears more intense than the previous one.
Now let's move on to the two threats associated with the raging sun. Let's start with solar flares.
In simple terms, this process is akin to the explosion of 1,000,000 hydrogen bombs. Magnetic fields twist and stretch, resulting in a detonation where even an atomic bomb detonated on Earth would pale in comparison to the solar explosions.
By the way, if you're interested in learning more about the history of nuclear testing, I recommend watching you a very cool video on the topic on our channel. The link will be in the description.
So, as you might have guessed, mainly in space, radiation is emitted as a result of solar flares. These emissions encompass visible light as well as radiation in the narrow sense, which we usually associate with incidents like Chernobyl or Fukushima.
But is this dangerous for humans? If we believe sensational headlines or various pseudoscientific theories, then certainly yes. Here, the risks range from traffic accidents and revolutions to epidemics and, of course, cancer.
However, in reality, solar flares are largely harmless for Earth's inhabitants, due to our planet's dense atmosphere acting as a night's shield, protecting us from incoming arrows. For example, this is why we launched the James Webb Space Telescope into space to capture infrared radiation from numerous stars and planets that doesn't reach Earth's surface. Exceptions include the ISS astronauts and airplane passengers, who can indeed feel the effects of solar flares. For instance, in August 1972, the Apollo 16 crew was on the moon and narrowly escaped the effects of solar flare radiation. Had they not, it would have likely killed them within a month.
For Earthlings, the negative aura surrounding solar flares arises from the frequent confusion and conflation of these flares with coronal mass ejections. This is an Avengers-level threat that we shouldn't joke about.
These two phenomena often occur simultaneously and are linked to sunspots. But in terms of mechanisms and essence, these processes are completely dissimilar. After all, a coronal mass ejection is essentially a spit in the face from the sun. Can you remind me what it's made of? That's right, superheated plasma and particles hurtling at insane speeds. During coronal mass ejections, the sun expels them into space. Imagine colliding with a river of lava, only hotter and moving at tremendous speed. Oh yes, and the sun ejects billions of tons of this lava. Just take a look at the bald Mercury and you will understand the impact of such an encounter. The meteorite that wiped out the dinosaurs is a child's plaything compared to a significant coronal mass ejection. Humans survive, as you're likely aware, thanks to the magnetic field. The solar particles expelled upon collision with the magnetic field and atmosphere create mesmerizing auroras.
It sounds beautiful, but in reality, we're dealing with a shock wave of terrifying proportions. Earth's magnetosphere is literally compressed, and the battle between solar wind protons and hydrogen atoms in our atmosphere is a true fight for survival. Scientists struggled for a long time to understand how we don't burn up, because even if Earth reflects all particles, the atmosphere should still heat up, potentially causing a simple fire to start.
It turned out that the atmosphere has an emergency mechanism to release the excess heat into space. And for this, it deserves a big thank you. Nonetheless, it's impossible to deflect all particles, which is why what is called a magnetic storm occurs. Underestimating these storms isn't wise. In 1859, the Earth was hit by the most powerful storm ever recorded. It's sometimes referred to as the Carrington event, named after its British discoverer. During the storm, the northern lights were visible nearly down to the equator. The storm shook the planet's magnetic field, causing a series of atmospheric phenomena over Cuba, the Bahamas, and the Hawaiian archipelago. Many telegraph stations were set on fire.
Imagine what would happen to the modern world, which is heavily reliant on electronics. Even the most conservative estimates suggest the damage in the US alone could reach a staggering $2.5 trillion. A fierce solar storm occurring today could lead to extended blackouts and internet disruptions. It's not unlikely that we might have the chance to test these assumptions and predictions, as we're currently in a peak period of solar activity. And these superstorms tend to occur with remarkable regularity during peaks.
For instance, the last superstorm was on July 23rd in 2012, and in terms of intensity, it was comparable to its predecessor from 1859. Earth was fortunate and there were no catastrophic consequences. The key factor is that everything in space moves and rotates, and mass ejections from stars are like bullets fired in completely random directions. This trajectory rarely intersects with Earth's path. In 2012, we narrowly missed an apocalypse by just 9 days.
From all of this, it can be concluded that coronal mass ejections and the accompanying solar storms likely don't directly impact all people on Earth. Among medical professionals, there is a consensus that people are scaring themselves and then suffering from their own fear. Or rather, there was a consensus.
In recent years, with the understanding that red blood cells in our blood carry charges, blood flow occurs in a magnetic field, and humans are involved in numerous processes related to electricity, the situation has changed. Now, a significant number of scientists acknowledge magnetosensitivity. It's linked to an increased number of heart attacks and strokes, pains in the musculoskeletal system, and many other issues.
In conclusion, magnetosensitivity to magnetic storms does exist, but it's not universal and not in the scale often presented by the media. And solar activity is definitely not a joke. Our star could turn life on Earth into a living hell at any moment, so it's worth keeping an eye on storm news. Particles ejected by the sun reach our planet in roughly a day. Therefore, in case of significant issues, scientists would be able to provide warnings. At least, that's what we hope for. It would be interesting to hear your opinion on the consequences of solar activity. Feel free to share your experiences with solar storms and whether you worry about the fate of our sun in the comments below. It was Anna from Earthwise Chronicles. See you next time!